Assalamualaikum dan selamat sejahtera. Hello madam. Okay, today I want to talk about presentation, the techniques of integration. Okay, first, my name is Auni Fidana binti Syamsul Akmal. Nombor matrix 01DKA 20F1086 from class DKA 2D. Okay, this is my friends. First is Nur Adiba Nazira binti Mat Zaini, nombor matrix 01DKA 20F1083 from class DKA 2D. Okay, last is Nabila binti Muhammad Tajuddin, nombor matrix 01DKA 20F1099 from class DKA 2D. Okay.
Hi and Assalamualaikum. My name is Nur Adibah Nazira binti Mat Zaini. My registration number is 01DKA20F1083. I'm taking part in explaining the meaning and the use of integration. Before we go further in this chapter, we must know the basic things of integration. It is to boost the idea. So, integration is the calculation of an integral. Integrals in math are used to find many useful quantities such as areas, volumes, displacement, and many more. When we speak about integrals, it is related to usually defined integrals. The indefinite integrals are used for antiderivative. Integration is one of the major calculus topics in mathematics. Apart from differentiation, which measures the rate of change of any function with respect to its variables, integration by parts and by the substitution is explained broadly. Then we will continue to the next slide. Okay, there's two types of integrals in math. The first one is definite integral. It is an integral that contains the upper and lower limits, then it is definite integral. On a real line, x is restricted to line which is x axis. The other name of the definite integral is Riemann integral. A definite integral is represented as shown below. So the other one is indefinite integral. Indefinite integral are defined without upper and lower limits. It is represented as shown below, where c is any constant and the function f(s) is called the integrand. Next, we move to the math integration. In mathematics, integration is a method of adding or summing up the parts to find the whole. It is a reverse process of differentiation where we reduce the functions into parts. This method is used to find the summation under a vast scale. Calculation of small addition problems is an easy task which we can do manually or by using calculators as well. But for big addition problems, where the limits could reach to even infinity, integration methods are used. Integration and differentiation both are important parts of calculus. The concept level of these topics is very high, hence it is introduced to us at higher secondary classes and then in engineering or higher education.
Hi, my name is Nabila binti Muhammad Tajuddin, number matrix 01DKA20F099. So today I'm going to explain ways to solve the question. So the question given, the figure 1 shows the part of the curve x plus 4 equal to 2y squared and a straight line p. So we need to determine the straight p. So to find the equation for straight p, as we need to know the equation is y equal to mx plus c. So we have the coordinate -2, 1 and 0, 0. And we need to find the gradient. The given formula to find gradient is y2 minus y1 divided by x2 minus x1. So we will get -1/2 for the gradient. So we have the m. And we can put into the equation y mx plus c. So we have y equal to negative 1 over 2x plus c. And we need to find the c-intercept. So it truth 0, 0. So we have c equal to 0. So the equation for the straight P is y equal to negative 1 over 2x. Okay, so we're moving on to the next questions. Find the coordinate A and B. The given equation is x plus 4 equal to 2y squared. So when y is 0, we will get x equal to negative 4. And now we have the coordinate A, which is negative 4, 0. To find the coordinate B, we need to do substitution method, which is equation 1, we substitute into the equation 2. So we have the first equation, x plus 4 equal to 2y squared. And the second equation is y equal to negative 1 over 2x. So we substitute equation 1 into 2. And the x we will get 4 and negative 2. But we need to cancel negative 2 because it's negative. So we have x equal to 4. When x is 4, substitute into y equation, which is the y equation is negative 1 over 2x. So we put x as 4 and we will get y equal to negative 2. And the coordinate B is 4, negative 2. Now we have the coordinate A and the coordinate B. For the last question is, find the volume of the solid form when the bounded area through 360 about x-axis. So we have volume 1 and volume 2 come out from the figure 1, which is the graph given. So we will get volume 1 and volume 2. And then how we need to find the volume 1 is using integration method. And we will get pi unit 3. Same goes to how we want to find volume 2. We use the same method, which is integration method, and we will get 2 over 3 pi unit 3. When we have volume 1 and volume 2, we need to add both volume to get the volume of the solid form. So when we add pi plus 2 over 3 pi, we will get 5 over 3 pi unit 3. So that's as the volume of the solid form when the bounded area through 360.
Okay, for the conclusion, the techniques of integration, we have seen that in situation is to derive a reasonable estimate for the integral of the function based on data points. The idea is to choose a model function going through the data points and integrate the model function. The definition of an integral shows that if you choose a null data points, the integral of the model function converges to the integral of the unknown function. So theoretically, numerical integration is on solid ground. Nonetheless, by using common sense together with a solid grasp of what the integral means and how it is related to the geometry of the function being integrate, the creative scientist, mathematician, or engineer can accomplish a great deal with numerical integration. Okay, so that is my conclusion.
And the last one, credits. This slide, including icons, image, ideas, and background sounds, were created by our own, which stand from me myself, Nur Adibah Nazirah binti Mat Zaini, Auni Fidana binti Syamsul Akmar, and Nabilah binti Muhammad Tajuddin. Big thanks to Madam Lim Yong Ching for guiding us, making this slide and presentation went perfectly as our plan. Thank you.